Welcome to Standard Math Problem of the Week. For this week's problem, we want to find an expression for the average of the roots of this iteration of a polynomial in terms of the average of the roots of the initial polynomial and the number of iterations. Now the answer to this is that the average of the roots is just invariant. To see this, first consider some polynomial p of x. Note that the average of the roots of this polynomial is just a n minus 1 over n times a of n. And this is because a n minus 1 over a of n is the sum of all the roots, and divide that by n, we get the average. Now consider a polynomial of the form So we're going to consider a polynomial q of x having n to the k, a term to the power of n to the k. And we have the coefficient of x to the n to the k is this thing an to the n to the k minus 1 over n minus 1. And the coefficient for x to the n to the k minus 1, b n to the k minus 1, is this thing, a to the n minus 1. N to the k minus 1, a n to the n to the k minus n over n minus 1. Note that b n to the k minus 1 over b n to the k times n to the k gives you back the same average of p of x. Now let's calculate p of q of x. So by plugging q of x into p of x here, noting that we really just want to look at the q of x to the n term to get the highest two coefficients, you'll arrive at that c n to the k plus 1 is really equal to an times b to the n to the k to the n, and c to the n to the k plus 1 minus 1 will equal b to the n to the k to the n minus 1 times b to the n to the k minus 1 times n times a to the n. This is just some basic algebra. Once we calculate it, we'll see that p of q of x takes a similar form. Really, we just replace k with k plus 1. And note that the average of the roots of this new polynomial is the same thing as the initial average. If we take c to the n to the k plus 1 over, or c to the n to the k plus 1 minus 1 over c to the n to the k times n to the k plus 1, we'll arrive at a to the n minus 1 over n times a to the n. So the roots, so the average of the roots of p of x, q of x, and p of q of x are all the same. Now the last thing we need to note is that if we plug in k equals 1 here, we get b of n just equals a of n, and b of n minus 1 just equals a of n minus 1. In other words, for k equals 1, we just get something like p of x. So that means we can think of the iterations. We can say k of 1 is our base case, just p of x. And each time we do p of x, we're really replacing k with k plus 1. And so from this, we see that the average of the roots stays the same, and that our base case is just p of x. And so over repeated iterations, our average is just going to stay the same via induction. And and that gives the solution. Thanks for watching. Please check out standardmath.org, check out our blog, and follow us on Facebook and Twitter. Thank you.